Hey guys, today we are going to once again sketch the graph of quadratics or parabolas. So this is part 2. We're going to go through each step slowly. I have my quadratic on one slide and my graph on the other, so I'll be flipping back and forth. But step 1 in graphing is to find our vertex. So our vertex is the opposite of our inside the parentheses number, which is -3, and the same as the outside, 4. So I go to my graph, and I go to the left 3, up 4. Make a point. The vertex is in the middle of my parabola, which also tells me my axis of symmetry is at x equals -3. So I'm going to make a line on x equals -3. The axis of symmetry is like a mirror. The axis of symmetry is like a mirror of our parabola. So what's on one side of the mirror will be on the other side of the mirror. Then, we have to find our x-intercepts. So to find our x-intercepts, we set y equal to 0. So we have 0 is equal to x plus 3 squared plus 4. I need to solve for x, so I'm going to subtract 4 from both sides. -4 is equal to x plus 3 squared, then square root both sides. The square root of -4 is positive or -2i, which is equal to x plus 3. To solve for x, I subtract 3, and x is equal to -3 plus or minus 2i. Since we have I in our solution, we know that this is an imaginary number, and our imaginary numbers do not appear on our number line. So we cannot graph our x-intercepts. That's okay. This information is not useful to us, but we just move on and find our y-intercept, which is when x is equal to 0. So we solve for y when x is 0. We need to use PEMDAS here, so we're going to use our order of operations. Inside the parentheses, 0 plus 3 is 3. So we have 3 squared plus 4 is equal to y. Y is equal to 3 squared is 9 plus 4 plus 4. So y is equal to 13. We go back to our graph. Y is equal to 13. So I'm on my y-axis and go up 13. Since there's a lot of y values, we have our slot of y equals 13. But if we didn't, then we would be able to pick an x value. So what I mean by when we can pick an x value is that we know as we go farther away from our axis of symmetry, our y values will continue to either increase or decrease if we have an upside down parabola. So here, as we get farther and farther away from our axis of symmetry, or the middle of our parabola, our y values would continue to increase. So if we pick 2 x values that are closer to our axis of symmetry, so if we pick -2, We then can plug in -2 into our equation. So I have x is equal to -2. We want to know what y is equal to find our point. So I plug it in. Y is equal to -2 plus 3 squared plus 4. So y is equal to -2 plus 3 is 1. 1 squared is 1 plus 4. 1 plus 4. Y is equal to 5. So now we have the point -2, 5 on our parabola, and we can graph that. We go -2 up 5. If we didn't have room originally to fit the 13, then we would have to move one x value over again to -1. So we plug in -1 into our equation to get y is equal to -1 plus 3 squared plus 4. So -1 plus 3 is 2. 2 squared is 4. 4 plus 4 is 8. So y is equal to 8. What did we plug in for x? -1. So our point that we can plot is -1, 8. Let's go back to our graph. -1 up 8. So if you just have the first 3 points, that's fine, because most graphs would not go up to 13 to plot our y-intercept. Our last step in graphing is to reflect over our axis of symmetry. So we go to each point that we have, and think how much does it take for us to get to our axis of symmetry. So our first point would be 1, so we're going to go 1 in the opposite direction and make a point. Our second point would be 2x values, so we're going to go 2x values in our opposite direction and make a point. Now that we have our 5 points, I can connect them. And I now have a sketch of my parabola.